Hi. So many of you wonder probably who is this guy on the stage and why I have to listen to him next 20 minutes. So first, you don't have to. And second, I do data visualizations. And usually I aim for like creative stuff, but of course I have to like aim for preciseness and for effectiveness. So for instance, I do something like this. This chart shows you distribution of letters in Ukrainian dictionary according to their positions. So basically, some letters appears closer to beginning of the word, some appears closer to end of the word, some somewhere in the middle. And I just calculated like relative probabilities, like probabilities for every letter to appear on a certain position in a word. It's something like, sorry, it's messed up like totally from what I can see on my screen and what I can see on your screen. So this shows like distribution of letters according to their positions. Pretty simple, something like 150,000 words, something like 3 million observations in general, and simple chart. Or I do something like this. It's a chart that shows distribution of temperature in Kiev for more than 200 years, and every horizontal line represents like average temperature for a certain year and a month in Kiev, and you can see general distribution, like spread of temperatures in Kiev. Or I do something like this. It's 3 years of music listening data of one of my friends, and basically every line represents one music listening session. Length of the line represents number of tracks in this session, and if a person discovers a new song which wasn't in her library before, line goes 1 point right to the right. And if person listens to the song that was in her library before, this line moves 1 step to the left. So basically, on this chart, you can see discovery we see versus repetition in music listening data, and you can understand some habits of user. So yeah, this kind of stuff I do. And now, like all of a sudden, do you remember this guy? Right? So it's a Detective Columbo played by Peter Falk in famous series, and why I like this series in special, because it's really interesting from storytelling perspective. Because in Detective Columbo, you know who's a killer from the start, right? There is no secret about it. Like from the first moment of each episode, you know who the killer is. And instead of waiting like all these minutes for revelation, you just observing process. You looking on how Detective Columbo will uncover killer, right? So you basically enjoying the process. And I like this idea of enjoying the process in relation to data visualization, because when I teach data visualization, I know that I have like many options, like teaching tools and teaching coding, right? Or like different libraries, or teaching like different chart types, for instance. But most of all, I like to teach process. Like I like really to teach people how to think about data visualization creation, from simple data frame table to final result. And today we will talk about data visualization process and decision we make in this process. So here result, he's the killer, right? So there is no intrigue. It's a simple chart that shows average age of first marriage in Ukraine by region and sex. And I usually say that like you can use this chart when you talk to your parents and discuss like your relationship plans. And here is the process. Well, short version of process, right? We have like starting point and we have an end result. And here we have like long version of the process. Like for each transformation I applied to initial data, we have separate picture. And basically, this animation is just a short version of my talk. I can just stop talking right now, and you can enjoy this animation. Okay? But not really. I will explain it. So we will start with something like this, right? So our data frame is really simple. We have just 3 variables. First variable is region, and then 2 variables for average age of first marriage for women and men. Really simple. And then we have to find like good way of encoding data for this data frame. But of course, first we have to define what we want to show, right? We have just 3 variables, so we can show them all. We can show average age of first marriage by region and sex. We can show difference between them. We don't have it in our data, but we can calculate it on the fly. And we want our chart to be sorted in some meaningful way. Okay? So now we have this defined. We can switch to data visualization. For instance, we have to find like good way of encoding data. And well, not like this, of course, right? Because this is a mess. But this is a good reason to discuss what kind of data visualization techniques or methods we can use, like visual encodings, right? And we can use several types of visual encodings, and they are not equal in terms of how they represent data, in terms of how effective they represent data, and how effective people can read data from these visual encodings. And how do we know that they are not equal? Because there is an actual science behind data visualization. Because sometime in mid-80s, 2 scientists conducted a series of experiments. And they were showing like pictures to people with same data encoded in a different way. And they were asking them, OK, what kind of numbers you can read out of these charts? And can you tell us difference between 2 numbers? And by analyzing results of these experiments, they realized that, OK, we have like most effective ways of encoding data and least effective ways of encoding data. And you see that, for instance, position on a common scale is the most effective way of encoding data because users, people can easily read this kind of encodings, and they can understand difference between data points. And like error in the readings is really like not that big. And if you want to encode data, for instance, in a volume or area, it will be harder for our users to read this data and to tell difference between 2 data points. So when we develop data visualization, we have to rely on this information. We have to decide, OK, what kind of visual encodings we want to use, what kind of level of precision we want to have in our data visualization, right? And also, there are many different factors as well. So for instance, here we have a lot of space used for encoding just 2 data points, right? There is no point to use so much space. And of course, length is a good way of encoding data, but there is no point to use so much space. We can make it much more simpler by using just 2 points, and we showing same amount of data with less amount of ink, with less amount of space used. And we are simplifying, we're reducing amount of visual noise on our chart. So we found encoding, but we have a lot of work to do on this chart. Let's emphasize what we want to show. We defined that we want to show not only average age of men and women, but we want to show difference between them, right? And of course, from this chart, you can like see difference. You can see distance between 2 points. But we can help our user, and we can emphasize it by using a nice light gray bar or line between these 2 points. So it's easier to understand that this actual difference. So we want to emphasize what we want to show. And we can apply many more transformations. So for instance, we have to add title, subtitle, and data source. Like, every chart without title and subtitle can be interpreted as data art, basically, because like you have to guess what's going on chart. So we have to add title and subtitle, and we have to add data source, because in this way we are showing our users that we didn't just make this data up, right? So we're adding titles and data source, and we're reducing grid. Grid is super important for like navigating chart space, but we have to use grid in a smart way, only when we really need it. And here we can reduce grid. We can just like reduce amount of grid on our chart. We can make our titles and subtitles bigger, and let's call it establishing visual hierarchy. And basically what we want to show, we want our users to understand like really quick what's going on. And we don't want them to put an effort in reading our chart. We want to minimize this effort. And simply by making our titles and subtitles bigger, we can help our users. And we can work with axis text. Probably it's harder for you to see the transformation, but here we have axis text numbers just down on a down axis, bottom axis. But our users usually read chart from top, right? So why use axis text on the bottom when our users need it on top, right? So let's make it on top. So we moved it. But also we keep axis text on bottom as well, because we have like 25 different regions, and of course our users navigate chart in a different way. So we will just double it, and we will have axis text on top and on bottom. And this simple move will help our users to navigate chart. And of course, we need to define in which intervals we will use for an axis text. And here we have default intervals, and of course we want to change it. We want to use intervals in a meaningful way. And let's add more. Okay? And in the next step, let's make another trick. Let's remove axis text where we don't need it. See transformation. We just removed everything that we don't need. And also, let's remove grid where we don't need it. So what we are doing, basically, we removing amount of visual noise on chart. And that's usually what we want to do when we develop data visualization. We want to remove visual noise, and we want to increase signal. Visual signal. Basically, here we're doing exactly that. We're removing all unnecessary visual information, and we only keep visual information that's important. And we can use more transformations here. So, for instance, we can find right place for legend. By default, we have it on the right side of our chart, but of course we have to think how our readers will perceive this chart, how they will encode it, and why keep legend on the right side if our readers start reading chart from the top, right? So basically we want to understand how our readers will read our chart and adjust all visual information accordingly. And here we just making a simple move. We moving our legend to the top. And next move, we want to move our axis text with regions names closer to actual data points. And of course, it's a simple move, but basically by doing this, we're reducing time of eye movement of our readers, right? So we're reducing distance between text and data points. And we're almost done, but we can do better. We can find better place for our legend. We can put it on basically subtitle and make it part of subtitle. So again, we just reducing amount of space we use, and we basically using space in more effective way. What else can we do here? We can change title and subtitle, because now we're using just formal descriptions, right? But when we use data visualization in stories, we usually have something to say. So for instance, we can change this title and subtitle to be statements, to be something like to be a part of story. For instance, to tell a story about girls in Zakarpattia region who are getting married really early. Or we can tell a story about 3 different parts of the Ukraine, because you can see a clear distinction between 3 different parts of, and basically we have like Western Ukraine, Eastern Ukraine, and then capital. And we can add, we can emphasize this story in a title, or we can emphasize this story in annotations. But for now, it's just formal description, right? And by using smarter titles and subtitles and annotations, we can draw our users' attention to like particular points in our story. And this could be really effective. So how this data visualization process basically works? We have to know what we want to say, because otherwise we will just create, I don't know, 20 different exploratory data visualizations without understanding what's going on. We have to find the best way of putting our data. And of course, we have to understand all trade-offs between like beauty of data visualization and effectiveness. Sometimes we can, like for a fancy presentation, we can create a beautiful visualization but not really effective. Or we can create something not very beautiful, but really straightforward and effective. And what we want to do in basics, we want to reduce our users' time and effort to understand our data and information. And we can do it by trying to understand how users usually read data, how they perceive visual information. And there is plenty research of that, for data visualization in particular, and for like user interface designs in general. And we should use it for developing data visualizations. And we have to test our data visualizations. So I do it pretty often, and sometimes those data visualizations I love most, unfortunately, least readable, you know, and I have to just admit that and get rid of that and use other ways of visualizing data. So, and like in user interface, we can use A/B testing, and we can use A/B testing in data visualization as well to understand how our readers understand charts or maps, and whether they understand them at all, or what kind of information, what kind of messages they can read from our data visualizations. So let's take a look one more time on this chart. Basically, here are all transformations of visualization for this project, but I cheated for this one. I added one more, like first slide, I didn't use it during the actual process, these bars, because I would never do that, because I understand that it's just stupid. So basically, that's all. If you have any questions, you can reach me. And you can read my blog with data visualizations, or you can reach me on Twitter. Thank you. Work that sucker to death. Everybody, work that sucker.